Hello, 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 my lovely students. Welcome back. Hopefully the test went well for everyone. At the very least, it's over. So now we're going to talk about rational expressions, these crazy fractions that we probably should have covered earlier because we've been giving you problems that cause these and we hadn't lectured on it. It's the one of the sequencing things we'll be working in future semesters. So my apologies for that. But now we'll get to dig into them. And this next week, you guys are going to graph some of these things. So that's why this week we're going to cover all the ins and outs. So a rational expression is a ratio or a quotient of two polynomials. Now remember, a polynomial can include just a constant term. So it could just be 0 or 1 or 37 million, or it can have variables in there. Once you start having variables in the denominator, though, you have the potential to divide by 0. We don't like dividing by 0, so we're going to first focus on just finding the values that would make us divide by 0, and then we're going to write a note that says, never let the variable be these. So a little silly, but that's the way we handle it. Now, what you guys are going to see in the graphs next week is this is how you find asymptotes or holes. So FYI, this particular skill is actually useful. Now, I want to figure out what makes me divide by 0, meaning what makes the denominator 0. So we set it equal to 0 and solve. So I have x minus 3. Yeah, let's make that a little bigger because I write so big. So I just take my denominator, set it equal to 0, and I solve. And I get x equals 3. So what this means is x cannot equal 3. That's our restricted value. X can be anything it wants except 3. -4 is fine. That makes the top 0 totally fine. Just means I'm going to have -4, 0 as a point. But x equals 3, nope. All right, over here on our next one, a little more interesting, we have a quadratic. Ooh, good thing we spent a lot of time on these. I'm going to use the square root property on this one because I can. So y squared is 16. We apply the square root. So we put a plus or minus. And we get y equals plus or minus 4. Or more appropriately, y cannot equal plus or minus 4. And then our last one over here is just a product on the bottom. So when I set that equal to 0, I'm really saying, well, either 7 could be 0. No, it can't. It's 7. Or a could be 0. Or b to the third could be 0. Which really just means b times b times b. So it's really just saying b could be 0. Meaning those are the restricted values. A can't be 0, b can't be 0. That is only because there's no addition or subtraction on the bottom. It's just a product, so any of the variables in there multiplied to 0 gives us 0 on the bottom. Bad stuff. So all of this is going to build towards solving rational equations. And when you solve those, you always need to check your answers because 9 times out of 10, especially on a test or a quiz, one of the solutions you get is going to be a restricted value, and you have to know to check it out and only use the remaining solution. Sometimes all of the solutions will get checked out, and then you just happen to have a no solution equation, which I know kind of feels like a letdown. You did all that work, and then that's your answer, but it can happen. So for the first few sections in ALEKS, they're going to ask, What's the restricted value? What's the restricted value? They'll give you a blank to type it in. Yay! And then after a while, they get lazy and they stop asking. And then it sneaks back in when we get to equations. So remember, you're going to need that skill for graphing. So be sure you're comfy with it. Now, our next stretch, the next few kinds of questions we have, these are just crazy algebra fractions. We don't have an equation, so there's no multiply both sides by the same thing because there's no sides, it's just one thing. So in order to solve, or sorry, not solve, solve an equation, you simplify an expression. So what we want to do here is factor, cancel stuff that's the same. The only things that can be canceled in these fractions, though, are things that are being multiplied. Like over here, the x plus 3 over 3 plus x. I can't go 3 and 3, x and x singly. Doesn't work like that. But I could say, well, I know 3 plus x on the bottom. That is the same as worst plus ever x plus 3. So I am not going to cancel x and x, 3 and 3. Do not write it that way. It's like a big math teacher pet peeve. I'm going to put parentheses back around them. So I want you to look at this as the thing x plus 3 over the thing x plus 3. Those things are the same. So we can cancel those things, one whole thing, one whole thing. Now, what is a thing divided by itself? Like 7 over 7, negative 2 over negative 2, 21 million over 21 million gives us 1. So I think there's one section in your homework where they give you these. They're kind of silly. So sometimes they're 1, or sometimes they're like the middle one here. So these, it's very similar setup, but addition is the same forwards and backwards. Subtraction, on the other hand, is not. So what we do on this one is on the top, because that's the one that looks backwards to me, but it doesn't matter which one, they both work. We're going to factor out a negative. I'm going to do it kind of weird at first. So the negative 1, so I'm thinking negative 1 times what would get me back to positive 2? That would be a negative 2. The negative 1 times what would get me back to negative x? So negative 1 times a positive x would get me back to the negative x. Now that's written kind of weirdly. Like the whole point of pulling out the negative 1 was so the x would be positive, so we could write it up front. So that's what we're going to do to that. No, sorry, not plus. That is x minus 2 over x minus 2. And again, same thing. The whole thing, and the only thing left is negative 1. Even if it was on the bottom, 1 divided by negative 1 would still be negative 1. So it is possible when you simplify to just get down to a number. Now remember though, we are canceling by multiplication division. So when everything cancels, you get a 1, not a 0. Now when we get to the addition subtraction later on, it is possible to get a 0. Not very likely, but possible. All right. So now we're going to go back to this first one here. So I see quadratics, Lux off the table. Cats. So we have quadratics here. Anytime we see quadratics, especially with these simplify, factor, factor, factor. Factor everything on these. Like even when we get to the equations, you're still going to factor any quadratic you see. We're even actually going to get a cube on one of them. Good thing we covered that. All right. So the good thing is on top, 2 terms, x squared minus 8x. Well, I just pull out what's in common, which is an x. Now I want you to notice I'm drawing arrows here. And that's so it doesn't ever accidentally look like an equation. Like I put it on the end because my habit is still to do the equals, but I want to draw a distinction like they are equivalent, but I don't want it to look like an equation. So suddenly you're like, oh, now there's an equation. Nuh-uh. All right. So the top, we factor out an x. Leftovers would be x minus 8. Now the bottom. So we can go through the whole process, find all the pairs, think of which pair is going to work, but I'll give you a ninja hint. Whatever you just factored, you're probably going to see. So let's take a wild leap of faith. Because none of these actually occur in the real world. It's just in Mathland where you get these disgusting things with pretty numbers. So if I put x minus 8 here, I want to think what would have to go over here, so it's going to multiply to negative 8. I have a negative 8, so I just need a positive 1. Then all we got to do is check, does the inside and the outside work out? So negative 8x plus 1x would be negative 7x. Cha-ching! So now it doesn't always work, especially when we start getting more than one fraction, it can get a little hairy, but 9 times out of 10 it does. So because the whole next step is cancel the stuff in common. The whole x minus 8 with the whole x minus 8. And our leftovers are just x over x plus 1. Now, some of you will have the temptation. You will see the x, you will see the x plus 1, and you want to cancel them and write something like 1 over 1 plus 1 or 1/2. Do not do it. X over x plus 1 is not the same thing as 1/2. It is if I put 1 in for x, but if I put 2 in for x, I get 2/3. If I put 3 in, I get 3/4. We don't know what x is. Could be 0. Can't be negative 1. Which I forgot to do on all of these is the restricted values. But so there is our simplified answer. And then back up here, our factored answer, restricted values come from the original before you cancel anything. So in the original, it's equivalent. This whole ugly fraction is equivalent to x over x plus 1 with the caveat that x is not allowed to be 8 and x is not allowed to be negative 1. Likewise over here, our two little fractions also have the restricted values. But this crazy fraction, if I graph it, it's actually a horizontal line. Very boring at negative 1, except for the whole at 2. Now on the calculator, you're not going to see the whole. It doesn't like graph a little circle for you or anything. But if you look at the table and you've got it set for integers or you type in 2, it's going to say error for the y value. So it also will say error when it's an asymptote. So you still got to look at the graph, but it will kind of find, or you can check, hey, does this value actually not work? Yeah, it doesn't. Cool. And then up here, of course. So this one, the graph is going to be the same as the horizontal line at y equals 1, but there's a hole at negative 3. So just kind of previewing what you guys are going to see next week with the graphs. This week, you're going to be graphing polynomials. You don't have to worry about holes and asymptotes yet. But you're going to go through a lot of graphing real quick. If you don't have a graphing calculator, I would recommend getting one before the last test. But you can Google like graph y equals, and then you use like x with the caret, and Google will actually graph for you. And you can actually kind of dig around in there as well, like move it around and stuff. So worst comes to worst, use Google. All right, so we got one more in this video. A little weird here. I've got 30 minus 10m, which I'm seeing the zeros. Okay, I know a 10's coming out, but the m's in the wrong spot, and I don't like that. So we're going to flip-flop it. We're going to factor out negative 10. So when we pull the negative 10 out, we have a negative 3 and a positive m. But if you just want to go ahead and write m minus 3, that's fine. And then on the bottom, difference of squares. Now remember, I harped on and on about difference of squares. They're going to show up a lot this week. You're going to see difference of squares so many times because mathematicians are lazy. I only had to type 2 terms for that. Well, the computer. All right, so m 3 plus minus. So what I'm going to do here is I'm going to cross this out and write above it how it really looks. All right, so that's so I don't have to write the whole entire algebra fraction again. Now I know I could copy paste erase the piece, put in the other one, but this is the way I would handwrite it. So now that I've fixed the way it looks, I can clearly see m minus 3 and m minus 3 on the top and the bottom. So those are going to get canceled out. We do still have restricted values. So m cannot be 3, m cannot be negative 3. And then we're just going to write our leftovers. So that is a negative 10 over m plus 3. Or you can put the negative sign in front of the fraction. Or you could even put the negative sign on the bottom of the fraction if you want. It looks weird though. But there is the rare occasion where that's actually useful. Like if everything on the bottom is negative, well then moving the negative to the bottom and multiplying through, now it's positive. It looks prettier. All right. Let's go ahead and work on these. Next up, as you can see, multiplying and dividing, but that will be in the next video.